Hello, this is Dr. Harper. This video is on Operations Management AMBA 6270, Spring 2021, the one-year MBA. And this video, I'm going over the homework number 4, which is MRP and scheduling. And so usually this homework was designed for discovery, for people to work through it. But because of this program, because of the brevity of the program and the accelerated nature of the program, I will work through these problems and show you how to work them. So hopefully you can work them with me and learn from me working through them. Okay, so let's bring up the assignment. And in this homework assignment, the videos that I recommend you to look at is the MRP 1 through 5 in the MD Harper website, but also videos 1 and 2 for scheduling. Okay, and I'll be using these videos when I work this problem, and also the lecture with the Zoom, which they require me to do. Okay, so you can use whatever you need. Here we go. First of all, it's MRP. And Company A is testing their MRP software by inputting a problem and checking the output from results calculated by hand. And I went over this in class to where this is a very common thing to do, and I would recommend this when you buy software. Put some test problems in to make sure, and do it by hand to make sure that it works. So the first question is, which day in the end item MRP has the greatest gross requirements? I talked about that in the lecture. What is the inventory policy for all 4 items? And remember, the inventory policy is the planned order release row of every MRP. And there's going to be an end item, A, B, and C item. So there's going to be 4, well, here they are, 4 items. And so this is the planned order release row, and that's the inventory policy. Well, which one of these is right, or none of the above? And finally, if the unit ordering cost is $150 per order, the carrying cost is $2 per item per day, then what is the total inventory cost, which is the sum of the total carrying cost and the total ordering cost during the time interval reported in the MRP for all 4 items. That is the 5 days, May 1 through 5. Okay, so what we do to solve this is working through 4 MRPs, pulling off the planned order release rows to determine the inventory policy, and then calculating the ordering cost and carrying cost of all 4 and adding them together. Okay, so that's this part A. So let's do it. Okay, first of all, let's pull this information here. Control C. Let's bring up Excel. And in Excel, bring up Excel. Here it comes over here. And I want to format this. There we go. And so I'll come down here, Control V, and paste this thing. We don't need all those lines in there. Okay, and that's going to be centered. Okay, and then first let's do the end item MRP. We'll start with that. End item MRP. So we're going to have the gross requirements, the scheduled receipts, the projected stock balance, and the planned order release row. So those are the things we want to do, okay? And then right here is going to be May. It's going to be May 1, 2, 3, 4, 5, right? And then down here, we want the lead time is going to be, well, this will be the lead time. And then this is going to be the safety stock. And this is going to be the lot size discipline. Okay, let me pull this down to here. There we go. Okay, now then, this is my end item MRP. Let's expand this a little bit. There we go. And so I'm going to take these values and populate it, and populate the MPS. But I'm also going to do this, and let's go ahead and box this in. So this is the end item MRP. I'm also going to do this for the A item MRP and call this A item. I'm also going to do this for the B item MRP. Call this B. I'm also going to do this for the C item. Call this C. And there we go. So now I'm just going to fill these in, pull off the plan order release row, calculate my my ordering cost and carrying cost, and that's this part A. Okay? Okay, first of all, for the end item, we take this demand right here, Control C, open up Excel back up, and let's enlarge this. And that's going to go into the end item gross requirements 1 through 5, and there it is, V. Okay, we'll start with that. Now for the end item here, there are no scheduled receipts. The beginning inventory is 150, so we'll move the 150 right here. The lead time is 1. Safety stock is 50. Lot size discipline is LFL. And there it is. So let's go ahead and do the next one down here. Now for the A item here, here's the A item. We do have a scheduled receipt of 24 on the May 1st here. So we come down here May 1st, scheduled receipts here. This is going to be 24. Then this will equal my beginning inventory for my A item, 65. And then over here, the lead time equals 1 for A item, 36, and 4. Fixed at 4. And there it is. Okay, let's do the B item. Now for the B item here, there are no scheduled receipts. Okay, so then 64 here, the projected stock balance, the beginning inventory is 64, and there it is. And then the lead time equals 1 for the B item, 20, and 8 plus. There it is. So now for the C item. Now the C item does have a scheduled receipt 9 on May 1st, so that's going to be 9. Okay, the beginning inventory here is going to be 58, and there that is. Over here, the lead time, that's going to equal 2. The safety stock is going to equal 25, and then the lot size discipline is fixed at 9, and there we are. So we have everything set up, and now we just generate. Let me take this out. Now we're just going to generate the MRPs. Okay, here we go. First of all, what I would do here, and also the video shows you how to do this. I'll do this by hand and work through it with you so you can see how to do it. Okay, first of all, this is going to equal your inventory on hand, which is the previous projected stock balance, plus your receipts with a lead time of 1. It's going to be the scheduled receipts. It's not there. I'll do it anyway. Minus your gross requirements, and there it is. Okay. Now on the second one, this is going to equal the projected stock balance on, which is the inventory on hand, which is a projected stock balance in the time period before, plus receipts. But this time, since the lead time is 1, the receipts are going to be down here, the plan order releases, which is 1 week behind, minus our demand, our gross requirements. And then I'll copy that over all the way to the end. Okay, so notice what I did here. So this right here is going to equal this plus our receipts minus our, this is inventory on hand, plus receipts minus gross requirements. Okay, right here, this is going to equal my inventory on hand plus my receipts, which will be, since the lead time is 1, the planned order release will be my receipts minus my demand up here. And then I'll do that each time. Okay. Now actually, now that I have this, I can take this this right here, these equations, Control C, and put them down here. I can put those down here, and then put those down here. So let's double check, make sure that it went okay. Is this true? 150 minus 12 is 138. Yes, because 138 plus 12 is 150. Right here, 65 plus 24 minus 0 is 89. So if I put 1 in here, that's going to be 88, 87, 86. And so we'll fill this in later. Likewise down here, this is just 64. If I put 1 in here, this is going to be 63, 62, 61. We'll fill that in. This is going to be 65, 66, 67. Okay, we'll fill that in. This is going to be 65, 66, and 67. Okay, we're good. Now what about C? Notice the lead time is 111, but for lead time of C, it's 2. Aha. So now what we have is 58 plus 9 is 67. And if I put a 1 in here, it goes 66, 67, this kind of thing. So I'm good to go. But for the second time period, my lead time is 2. And so this right here does not equal the red. This should be up here in schedule receipts. So the red is D31. So I'm going to take this and replace this with E29. Okay, but then from then on, it'll be my schedule receipts. I mean my planned receipts. Okay, and so there we have it. Okay, so we already have this up here, and let's go ahead and change it to be common. Okay. Now we have everything set up except the planned order POR, the planned order release row. Okay, so the safety stock is 50. Okay, we come across here and we're fine, 50, 50, 50. Right here, it drops below 50. How much below 50 is it? Well, it's going to be, what is that, 16? Yes. So lead time is 1. I come back 1 and put 16 here, and it jumps up to 50. Okay, then it drops down to 40. Okay, my safety stock, I have to put another 10. And there's my end item MRP. Okay, now we reduce this a little bit and we say, okay, what's next? Well, we have our end item MRP already. What's next? Well, the next is either the B or the C, either one. We can't do A because C is the source of A, but end item is the source of B and C. So let's do B next. The multiplier is 3, and end item is the source item. So down here, B, for the gross here, the multiplier is 3 per end item. Whoops. Okay, right? Yes, 3 per end item. Good to go. Okay, so this will simply mean, right here, this will equal 3 times I go to my end item, I come down here to my planned order release row, and click that. And then copy that over. And there it is. Now I can fill this in. Okay, my safety stock is 20, 64, 64, 16. Okay, it drops below 20 by 4, but my lot size discipline is fixed at 8. So my lead time is 1, I come back 1, and I order 8. And that jumps above 20, I'm fine. Here I have a minus 6. Well, then minus 6 up to 20 is 26. Well, 26 is more than 8. Everything above 8 is lot for lot, so this would be 26. Okay, and so there we have B. Okay. And so there we go. Very good. Okay. Then what's next? Let's do C. The multiplier is 2. Here we go. The multiplier is 2 right here per end item. Okay, again, we come up here and we say equals 2 times. I go to my source item, my end item, and I want the plan order release row right there. And then I copy that over. Okay, my safety stock is 25. I come across here, 35.15. My lead time is 2. I come back 2 right here. My fixed lot size discipline is 9. So I need how much do I need? I need 10, right? 15 to 25 is 10, but it's fixed at 9, so I have to have 18. There we go. And now I'm good. So now the last one is A. My multiplier is 4. My source item is C. Okay. So for my A item, multiplier is 4. My source item is C. Correct? 4 and the source is C. 4 and the source is C. Correct. So now I come over here, it equals 4 times, I go to my source item, which is C, I come across, and my plan order release row right there, bam. And then I copy that over. And there we go. So now, my safety stock is 36, and it jumps below 36 right here. My lead time is 1, I come back 1, so my lot size discipline is 4. So from 17 to 36, how much more do I need? Looks like I have like 19 more. Let me just see. Yeah, I need 19 more, but it's fixed at 4, which is 4, 8, 12, 16, 20. So this has to be 20, because that's multiple of 4. And I'm good. It's above. I'm good to go. And so there it is. Okay. So at this point, what is the inventory policy? Okay, we're going to have our end item, A item, geez, A item, and then B item, and then C item. Okay, and we're going to have May 1, 2, 3, 4, 5. And essentially all you do, this is going to equal the plan order release row of POR right here, that right there. This is going to equal my A item, which is right there. This is going to equal my B item, which is right there. And this is going to equal my C item right there. And I just copy that over, and there's your answer. And you see which one it is. Okay? Good to go. Okay, now the next question, though, down here, is if this cost $150 and 2, then what's the actual cost? Okay, right here, let's do the cost for the end item. Okay, first of all, we want the for the end item here. First, the average inventory. Okay, let's get the average inventory, and then the order frequency. Okay, so let's do that right here. That equals count if And the range is all of these, count if, and then I'll just say if it's greater than 0. Let's see if that works. Yep, there's 2 of them. Okay. Actually, I'm going to do it this way. Okay. Now let me pull this over and do it this way. Let me think here. That's my order frequency. Now this right here is going to be my average inventory. Okay, remember it's the average of all the inventory on hand, the beginning and ending inventory. So it equals the average of what's the inventory on hand? It's the projected stock balance of the previous time period. So that's going to be all of these right up to 4, comma, the ending inventory is these all the way to the end. So that's the beginning and ending inventory. And there they are. Now that I have that, the reason I did it this way is because I know what I'm going to do here. Let me copy this down and just copy this all the way down to the end. All the way down to here. And then let's say, okay, I want the frequency here. I want this down to here. I want this down to here. And just delete this down here and delete. So there's my frequency. Now my average inventory is this down to here. Is this down to here. And this down to here, and delete that. So there's my average inventory. Okay. So now what you can do down here is you can say the MRP for the end item, boom, boom, boom. And here you can say your order frequency, average inventory, okay, and then right here you'll just say equals this equals this, etc., etc. This equals this, this equals this, etc., etc. Okay, and then you sum these. Well, I guess I should go ahead and just do all of this. Equals this, equals this, this equals this. Okay, so here's a frequency, average inventory, correct? And so you sum all of these. There's all the order frequencies, and there's a total average inventory, the unit cost. Let's see, what was the unit cost again? $150 per order, so this is $150. And this is $2 per item per day, but there's 5 days, so it's going to be $10 per item per 5 days. And so the total cost equals 6 times 150, and copy that over, bam, 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 and there it is. And then you add those two together to get your answer. Okay? And I'll let you do that. And this, you just copy this over, and you copy this over to get your answer. So I'll let you do that. So I did work it, but I'll let you complete it. As I say, I don't want to steal your thunder. Or you guys can help each other and some work some, whatever, however you want to do it. Okay, that's your business. Okay. And actually, the mistake I made, I see there's a mistake in my spreadsheet here now that I'm working it out. Because I don't work it out, I just change things. I didn't change everything. The problem that I have is that this right here, let's see here. Let me pull this down. Here we go. Okay, let's see here. Ding, ding, ding. Okay. Yeah. This right here should be 26. Because B is the answer to this one. So I'll tell everyone that. So hopefully everyone will see this. I'll change that in I change the answers. I'll pull down the homework and change the answers because it should be 26 because B is the answer. And down here you can add this up. I don't know what it is. I'll change these answers too because I think what it is. I don't know what it is, but you can add them together and have the right answer. So I'll have to change the homework because there's a mistake in my notes. I just found it. Okay. In other words, everyone's going to get all this stuff right. They should. Okay, let's go on. The 4, 5, and 6. Now here's scheduling, sequencing. Let's see if I did this right. This is a good quality check to make sure I do it right. I worked through it by hand. Anyway, here we go. At the beginning of each planning cycle, a company receives a project of jobs, creates a schedule, and begins processing the jobs to ship their customers upon completion. In other words, they ship it and send it out, okay, and they bill them and they get their cash flow. For the next project, they obtain this information, and there it is, okay. And then what is the time of completion of the project? A common concern, and then approximately how many jobs are laid. Essentially, what you do is pretty much let's bring Excel back. Take these jobs here. Control C, and it's just going through. Let's just a new spreadsheet here, and bring down and put it here, and there it is. I can bring this over like this. I could let me format this thing. There it is. Okay, and there it is, and then I can format these. I don't want to format those. I want to format this. There we go. And then increase this equals 85 and just bring this over. Okay. And so essentially, if I over here sum the processing time, that's the total processing time. It's just the sum of all the times. Because an n-by-1 system, it doesn't matter the order. It doesn't matter the order, right? And so there it is. So that's the answer to the first one. Okay, now let's do the next one. A common concern is to return jobs as soon as possible to accelerate billing. The metric used to accomplish this is to minimize the average time a job will be held in-house before distribution to the customer. Well, the average time a job is held in-house is the flow divided by the number of jobs. So if you minimize flow, you'll minimize the average time of a job. Well, what minimizes flow? The MPT rule. So we have to use the MPT rule and then we'll have it. And how many jobs are late when the average time a job is held in-house is minimized? Well, it's the MPT rule, and you go to the lateness. Okay, so let's do that. Now we know what to do. Let's do it. Okay. Well, first of all, we need to rank order these from minimum cost, minimum time. I mean. So what I'm going to do is take this right here, Control C, and let me move it over one. I guess I'll do it here, and then let's transpose it, and there it is. Okay. And then copy it again, and then I want to put the numbers in there. And now let me, oh well, we'll keep it this way. Here's a job, here's the processing time, here's the due date, and this is the start date. Let's just do it that way. Much easier just to do that. Okay, now then the flow. Let's get the flow. that's going to equal the processing time equals the processing time plus the previous queue time, and then add that down. Okay, then we sum this. This is auto sum, and it's 626, and there it is. Oh, yes it is, but I didn't do the minimum processing time. So let's highlight this. Data, sort. My data does not have headers because I want to take column C. Right here, column C, I want it to reorder this and sort it from smallest to largest. Boom, and there it is. 486 is the actual time. Notice before it was 600 and something. Now the flow is 486. This is a minimum because now this is the NPT rule. And there you go. And there it is. Okay, but for the average flow, let me just say time per job, okay, is going to equal this 486 divided by I think it's 9. Just say count. Count all these, whatever these are. It's going to be 54. Okay. Car 54. Where are you? Okay, so that's the idea. That's that's going to be the minimum time. Okay, and there it is. Oh, 54 right there. There it is. 121 is the time of completion. That's the actual minimum time. The average time a job is held in the system. That's the lowest time. Now, what about lateness? How many jobs are late? Okay, well, remember we have date of completion. That's going to equal the present date, or the start date, plus, actually it's the present date, sorry. That's a present date. I think I even said present date up there. I said present start date of the project. Well, that's the same as a present date. It's a present, the start date, the date of the project starting. So I call that the present date. So this is going to equal the present date plus the flow. And that's the date that it will be completed. Okay. And then if the date of completion is greater than the due date, it's late. Okay. And so here I'll just say equal if the date of completion is greater than the due date, then I'll just say a 1. Otherwise it's a 0, and I'll just sum them up. Okay. In other words, I'll just down here, and then I'll just sum these up. And there it is. We're going to have 5 days that are going to be late. These 5 jobs are going to be late, and there they are. And basically, that's what this is about. I did this quickly, but the point is, you can set this up, and suppose you had different times here, and so you can change these times and do different things. Okay, that's enough of that. Okay, the next one is part C. An organization that continuously processes a proposal is addressing a large backlog due to a historical FIFO sequencing rule. And here's the FIFO sequencing rule. And I just sequentially numbered them 1 through 20. There's 20 proposals here. You have been asked to determine a schedule that minimizes the processing time of the project proposals through the editing department and revision department. Okay, minimize processing time. The editing department identifies changes. The revision department incorporates changes and produces a final proposal document for release. A proposal must pass through each department. Each department has personnel to service only one document at a time. The editing time is dependent on the type of proposal, revision time. Okay, I mentioned all this in the lecture. So what we want to do, there's a number of things you recognize here. First, recognize that it's an n/2 system. From this description, I'm describing an n/2 system. 2, to determine the minimum processing time, recognize that you have to do Johnson's rule. 3, do Johnson's rule, and then answer the question. Answer these questions down here. Oh, do Johnson's rule, and then get the minimum processing time. What's the idle time for the editing department? What's the idle time for the revision department? How much time is saved between FIFO and Johnson's rule? So that's what we're looking at. That's what we're doing. Okay, so let's do it. Let's do it. And by the way, these kinds of things can be used for not only FIFO, but also for Johnson's rule, to say, look how much the idle time changes, but also the processing time changes. So it's optimizing your operations is what you're doing. Okay, let's do it. Let's highlight this. Let me show you how this is done. Let's highlight this, Control C. Bring Excel back. Open a new spreadsheet. Come down here a ways, and then Control V. There it is. Let's do this. And let's come up here to Arial 10. And then center everything. Make sure it's centered. Okay, and there it is. Okay, the first thing we want to do is Johnson's rule. Okay, the first thing up here is early versus late. Okay, and so that's going to be an if statement. If this, the time on the first server is less than the time on the second server, then I'm going to label that L for late. I'm sorry, E for early. If it's false, it's L for late. So when the shorter time is on the first server, if that's true, then it's going to be early. Okay, and then I copy this down. There we go. Okay, now the early there is all through, so what I want to do here is take this and say, okay, I want to sort it again. Data, sort. I do not have headers. I want to sort F. So here's column F, and I want E then L. So A to Z, E is before L in the alphabet, so it's E to L. But then I want to sort also the editing time. I'm going to add a level, and on the second level, it's going to be column D, which is smallest to largest. Say OK, and there it is. Okay, but it's smallest to largest down here. And now the late here, I want this over here to be largest to smallest. Okay, and so I'm going to sort again on this part here. I'll delete one of these levels, and I want to sort on E, column E here, but I want this to be largest to smallest because I want the smallest down here. That's the Johnson rule concept. Ready, go, and there it is. Smallest to largest, smallest to largest. There's Johnson's rule. Okay. So now to generate this, first I want to have the early start on the first server, early finish on the first server, early start on the second server, early finish on the second server. And so here is essentially the start, finish on the server 1, server 2. And so now we're using the concept of an n/2 system. And I'm doing it this way because I'm going to create a Gantt chart. Because when you do this stuff and you're reporting at a Gantt chart is always helpful. And I'll show you how to do that. Okay, first of all, the early finish. Well, the early finish is just a flow. So that equals this editing time here of 7. Okay, and then this is going to be 14 plus 7. And then you just copy that down, and that's the flow. The flow is when it's going to be finished. Early finish on the first server. The early start is simply the early finish minus the duration there. Okay, and so I could have just copied it down, but I'm doing it this way because I'm going to do the same thing on the second server. Now the second server. Okay, this equals the processing time plus when it starts. When does it start? Well, it starts when the first one is finished. There it is. Okay. Now, this second one then equals the processing time plus when it starts. But when does it start? Well, notice this job doesn't finish until 21, but the second server is available on 19, so if the second server is still busy past 21, it can't start. So it has to be the maximum of these two times, of that time, comma, that time. Okay, and I say that in the video. Return, copy that down. Good to go. There it is. Okay, and then again, the early start equals this minus the processing time because you just backward schedule it, and there it is. Okay. Now, the total processing time is just going to be, remember, the flow of the last job in a schedule is the total processing time. So it's 453, and there it is. So I said I'd work it, and there it is. Okay, let's come out here and say, what is the minimum processing time in minutes? Well, it's 453. What's the minimum processing, for the minimum processing time schedule, what's the idle time of the editing department and idle time of the revision department? So let's get the idle times. Okay. Well, first of all, for the, let me box this in because that's going to be my answer for the first one. Okay, what about the idle time for the editing department, the first server? Well, notice it's continuous all the way up to 440, but then it's finished on 53, and so the idle time here for the first server simply is 453 minus 440, and it's 13 days. Now, what's the idle time for the second server? Well, that's a little different. Okay, up here, I can say idle for the second server. Well, first of all, it's going to be the processing time on the first server here because it has to wait till the first one gets done. But then after that, you're going to have idle time whenever the second server has to wait for this to start. Like this finishes on 19. This will start on 21. Okay, so it finishes on 19. It's ready to go. Okay, but the it can't start until 21. Okay, so the way this is going to work is if this number is greater than that number, that difference is going to be the actual wait time for idle time of the second server, waiting until that job is available. Okay, in other words, if this is greater than 19, then I take that difference minus 19, that's going to be the wait time. Otherwise, it's 0. And there we go. And then I can copy that down. All the way down to the end. There we go. And now I'm going to sum this. Auto sum. And I have 18. And so the idle time for the second one is 18. So the answer is 13 and 18. Okay. But then the question, the last question though, is how much processing time is saved between the FIFO schedule and the minimum processing time schedule. Oh, okay. Well, you know, probably the best way to do that, this is the Johnson's rule schedule, minimum processing time. Tell you what, let's do. Hold down the control, copy this over, okay, and then let's come back up here and take, here's the FIFO schedule. Let's take all of this, Yeehaw. Whoop, do it again. Really telling you aggro on us here. There we go. Control C, and then let's bring Excel back on this new spreadsheet, and let's just put these right into here like this, and paste. Paste. Okay, and so we can see here it's 472. Notice it's still 440. That doesn't change, but this can change because it's an n/2 system. So these right here, I'll say time of completion equals 472. So these right here, let me take this, Control C and copy this, come back to this sheet over here, and let's paste this, whoops, and paste the values is all. And this right here, time of completion equals 453. And right here, okay, well, first of all, this minus this, look at this. You're saving 19 days. 19 days of the time of completion, which is the 19 days for the idle time of the first server and the second server. Very interesting. Okay? But then again, you answer the questions, but what about the Gantt chart? Let's move this down out of the way. What about the Gantt chart? Well, that's a good question. Let's build a Gantt chart. Okay? Well, first of all, I can bring my proposal over here. Let's see here. Let's a Gantt chart of the Johnson rule schedule. Let's do that. Okay, so first of all, our proposal. I want to take this. What I want to do here is take these and format them. Let's make these bigger, and then format it this way. Because I don't, and then we'll format it this way. Because I don't want a bunch of space in there. Okay, what I want to do here, first of all, this will equal my proposal. I'll be copying that down. Okay. Now, what we want now is we're going to have a bar chart. We're going to have a Gantt chart here. And so what we do is for these proposals, let me just go ahead and copy this down. All the way down to here. Okay. Now we want to have a start, finish, but it's going to be a bar chart. Okay. And so where do these start? It's going to be the early start, because that's when all these are going to start. Okay. And then you do that. But then the next one is going to be the time, is going to be the time on the first server. Okay, so let's just come over here and bring this, is going to be the editing time. This equals the editing time. So once we say here's when you start, but then here's how much you're going to process. So that needs to be the next bar. There it is. Okay, then you need the queue time. For in front of server 2. The queue time in front of server 2. What's that going to be? Well, the queue time is when the job finishes and waits to start the next job. So that simply will be this early start minus the early finish. And we'll just copy that down. And there we go. Okay. And that should be an inverse of the idle time. It's either idle. If it's not idle, then it's either 0 or you have a queue time. Okay. See this last one down here for anyway. And then finally, it'll be the processing time, the time here for the second, T2. which will equal this the revision time hit. We copy that down. Move this out of the way so you can see what's going on here. There we go. And there it is. Well, there it is. Now we just have to plot it. So let's take all of these right here, come up here to Insert, Bar Chart, a stack bar chart, and there's our Gantt chart. Okay, we need to format it. The first part here, okay, right here there's going to be no fill and no border because I want that to be blank. Okay. Also, clicking this over here into the axis options, categories in reverse order, and there it is in reverse order. Let's go ahead and box this in because we'll want to box this in to be a little easier to see. Okay, we're going to format this here. We don't need this anymore. Okay, well, also, look at these times here. We don't want this. Double-click this, and then come up to Select Data. And over here, you can edit the data, and essentially, you want these times over on the left. And say OK, and there they are. I mean, you can't see them all. It's 12. We have to broaden it a little bit here, and that's OK. Okay, now let's format this so we can actually see what's going on. And so actually, let's broaden this a little bit more. Bring this down. Broaden this even more. So notice right here, these blue in here, this is the queue time. Okay, so we want to highlight these. Boom. Didn't get the last one here. I think I did. Highlight these, and then again, no fill and no line, return. And there they are, and there's my Gantt chart. Now the orange and gold, let's solid fill, let's just make this a gray color of some kind. And then the border is a solid black. Okay. And then the second one here, it's a solid fill, but make a little bit darker. Let's see, yeah, that's a good one. And solid lined for this one. There they are. Now let's change this up here for the axis options. Let's make this, it's 50, but let's make it 20 maybe. Yeah, that's good. Okay, and now this is a Gantt chart. You can play around with this and do it the way you want. Oh, we can have axis lines in here. I like the axis lines. Add chart, axis horizontal. Grid lines horizontal. There we go. So we can kind of follow it through, you know. Anyway, then that's how you build these Gantt charts. And that might be helpful, not for this homework, but it might be very helpful when you're doing projects, any kind of projects in any kind of company, and you have a bunch of data. You got your Gantt chart, and this is what you're going to publish. You can copy this. Actually, if you want to copy this, home, copy as a picture, as shown when printed. Okay, it goes into your clipboard right here as a plot. I bring this back. Now this is a Word file now. Back to my Word file. I can bring this down and say, okay, I'll tell you what I want to do here is I want to paste my graph. There's my graph, and you can bring this over here and say, move it around, and you can move this and overlay it, and there's your Gantt chart. And you create your report. Again, communication should be part of this. And I think I've mentioned this before with memos or projects or PowerPoints or whatever. You can put this in a PowerPoint too. You can bring up your PowerPoint and put it in PowerPoint. But anyway, that's enough. As I say, I get carried away. I hope this helps. This is homework number 4, and I have the answers in there. And I'm going to change the answers and post the answers the correct answers so that you'll see exactly how to, what the answers are, and all the answers are in this homework. So hopefully everyone will get these right. That's all I have for this video. I hope this helps. Between now and next time I see you, stay healthy, keep learning, and take care.